This is Kristen Parsons from Athens State University. Today we have breaking news on quantum computing. Google has released a statement that in the next 5 years, they will have produced a viable quantum computer. Other companies have been working on quantum computing technologies, so this has created competition between the companies. Now I'm going to turn it over to Russell Brandom to give a quick overview of quantum computing.
A conventional computer uses electrical circuits as bits. A quantum computer runs on quantum bits, or qubits. Tiny particles magnetically suspended in extreme cold, just fractions of a degree above absolute zero. The idea is to keep each qubit in a state of superposition, so it's simultaneously a 1 and a 0. That allows for something researchers call a quantum speedup. With the speedup, each qubit increases computing power exponentially. With enough qubits, that power starts to go really fast. It won't help much if you just want to check your email, but it lets researchers tackle complex problems like weather prediction or materials analysis that are still really difficult with conventional.
From listening in to Russell, we see that quantum computing could change the way we solve problems drastically. It could not only change the ability to solve problems, but the speed as well.
Next, we will look at the timeline of quantum computing development. It dates back to 1981. There are many milestones that have been made over the years, so we will just talk about a quick overview. The development of quantum computing started its progressive journey in 1981 at a conference by MIT and IBM. Through the years, small changes and developments added up to big breakthroughs and successes. In 2016, IBM made quantum computing available for the public in the cloud so that anyone can access and run experiments on IBM's quantum processor. Although we don't have quantum computers sitting around at our fingertips, through the developments from IBM and Google, amongst other companies, quantum computing is on its way to becoming more common. Quantum computing could be greatly beneficial in an educational classroom. The amount of information a quantum computer could sort through would allow for extensive research to be found in a shorter amount of time than if using a classical computer. Quantum computers use optimization to help choose a solution. This could be useful to use to sort students into classes once all the information was put into the algorithms. The amount of research that could be done would greatly benefit teachers in their research and students in their studies.
Thank you for tuning in for our news on quantum computing. Before you go, please check out our resources we used.
Here are the resources we used.